So this is the basic hydrolysis of an amide to a carboxylate ion and an amine. Under the conditions of this reaction, we have hydroxide and water present in this reaction. These are basic conditions. That means that there's no acid, so throughout this mechanism, nothing is going to protonate and form positive charges like our mechanism under acidic conditions. Under the conditions of this reaction, that hydroxide ion is a very good nucleophile. That means that that hydroxide ion is capable of directly attacking that amide. So it's going to donate electron density towards the carbon of the carbonyl, kick the electrons up to the oxygen, and that's going to give me a tetrahedral intermediate. Now, this tetrahedral intermediate currently has two leaving groups. Our leaving group choices are a hydroxide ion or an amide ion. And without a doubt, it's the hydroxide ion that is the better leaving group under the conditions of the reaction. So when this reaction runs and this tetrahedral intermediate forms, the vast majority of the time, this tetrahedral intermediate will collapse, kick out that hydroxide, and send us right back to the amide. So that this is a reaction that's going to take a lot of time, going to take a lot of heat in order to effectively hydrolyze that amide to the carboxylate ion and the amine. But just like what we saw with saponification, in this reaction, if this tetrahedral intermediate collapses, and if it kicks out that amide ion, 99 times out of 100, this is not going to happen. But the one time out of 100 that this does happen, the products that we're going to get are this: a carboxylic acid and an amide ion. This is a reversible step in the reaction because that amide ion could come right back and attack that carboxylic acid and get us right back to that tetrahedral intermediate. But what can also happen between these two components is that my amide ion is the conjugate base of ammonia. And we know that ammonia has a pKa of about 35. That means that that amide ion is a very strong base. And this carboxylic acid has a pKa of about 5. So that this acid-base reaction is going to be very fast in your reaction if we have this process happen. Even one time out of 100, one time out of 1,000,000, every time this process happens, this amide ion is going to grab that proton from the carboxylic acid, give those electrons to the oxygen, and that gives us that carboxylate ion and the amine. And when we form that carboxylate ion and the amine, we form that through a process that's irreversible. That carboxylate ion is a pretty weak base. That molecule of ammonia is not very acidic at all. So when we form that carboxylate ion and the amine, there's no going back in that reaction. So that as we form that product, our carboxylate ion will form a salt. It's going to be precipitating out of our reaction. Its counter ion can be the sodium cation that we have from the sodium hydroxide. And as it forms a salt under the conditions of the reaction, that's going to help to remove that product and drive that reaction to completion in accordance with Le Chatelier's principle.